Hey everyone, welcome back to our SAT practice. Today we're going to continue where we left off in our last section, in our last video, which was the 2018 Official SAT Study Guide, Practice Test 1, Section 3. And we're going to pick up on problem number 11. So in problem 11, we're told that B equals 2.35 plus 0.25x. C is equal to 1.75 plus 0.40x, where B is the price per pound of beef, C is the price per pound of chicken, and X is the number of weeks after July 1st. And what we're asked to find is the price per pound of beef when it was equal to the price per pound of chicken. So how should we go about handling a question like this, right? If you're algebraically inclined, you might see right away that a reasonable strategy would be to set these two equal to each other, find the value of x, where these two are equal to each other, and then use that to find the price of beef. But I think that in this practice, it's really helpful for us to use this as an opportunity to develop a little bit more insight and take our time and actually build out the graphs, right? So let's go ahead and do that. So it's not very time consuming to build this kind of graph, so we'll look at we'll graph this out. So we'll have x as our input. I'll represent beef with this green series, so we'll say this is, let's say it starts off at 2.35, and we know that it goes up by 25 cents each week. I'll use let's say orange for chicken. It starts off a little bit lower, but it increases at a rate of 40 cents per week. And what we're asked, and so what we need to do is actually find this point, right? So we'll call this point x star. And x star represents the time at which the price of beef, right, so B of x star, is equal to the price of chicken, so that's C of x star. And once we find x star, we actually have to go back and find the value of our functions. So let's go ahead and do that, right? So B of x star will be 2.35 plus 0.25 x star. Right, so I'll write this out. So B of x star, that has to equal to 1.75 plus 0.40 x star. And this is C of x star. So what we're doing here is literally writing out this equation explicitly. And now we can solve for x star. So 0.60 equals 0.15 x star, which implies x star equals 4. So 4 weeks after July 1st, the price of chicken was equal to the price of beef. Now what was that price, right? So we go back and plug that in. So that's 2.35 plus 0.25 times 4, which is equal to 3.35. So our answer here is D. Okay. So now let's consider problem number 12. In problem 12, we're told that a line in the xy plane passes through the origin. So we know that x1, y1 equals 0, 0, and it has a slope of 1/7. And we're asked to find which of the following points lies on the line. So using these two pieces of information, we know that the equation of our line is going to be 1/7x. So if we kind of draw it graphically, it looks something like this. And now we're asked to find which of the following points essentially satisfies this equation, right? That's what it means to lie on this line. So the way that I would recommend doing something like this, right, is building yourself a table. So we have our x and we have where y equals 1 over 7x, and then let's say this is our answer choice, right? And what we want to do is find where our table matches, where our expected value of y in this table matches our answer choice. So when x is 0, our expected value of y should be 0, and that makes sense, right? It goes, the origin lies on this line, and in fact our answer choice here is 7. So A is not going to be the right answer, right? If we plug in 1, we get 1 over 7, which again is not equal to 7, so B is not the right answer. If we plug in 7, we get 1 for y, right? 1 over 7 times 7 is 1, which is not equal to 7 again. So C is not the right answer. So now we better hope that D works out. So let's see, we plug in 14. 1 over 7 times 14 is 2, which does in fact equal 2. So the only answer choice that works is D. The only location where our table matches up is corresponds to answer choice D. So that's our answer over here. So now let's go on to problem 13. In problem 13, we're told x is greater than 3. X is greater than 3, and furthermore, we're asked to find an expression that's equivalent to 1 over x plus 2 plus 1 over x plus 3. Now you might be wondering, well, why are we given this kind of constraint on x? And usually this type of constraint is put in place to actually help us, and it helps us avoid, let's see, avoid divide or division by 0. So division by 0 is illegal, and if we have this constraint in place, typically the College Board is actually trying to do us a favor, and it eliminates that possibility altogether. So in this, I think this is a good opportunity. This type of problem is a good opportunity for us to be very explicit with how we handle some of these simplification problems related to fractions, right? So that's actually the whole point of these kinds of practice videos, is to be really explicit, work through all the steps, where we don't want to skip anything. And I think this is one problem where skipping steps is actually common, and that's what's going to lead to mistakes. So the approach that we need to take here is to find a common multiple of the denominators of our denominator, right? So common multiple of x plus 2 and x plus 3. So the lowest common multiple in this case, since x is unknown to us, is x plus 2 times x plus 3. And since we want to, we don't want to change the value of this expression, that means that we can only multiply by 1. So that must mean that the numerator must be equal to the denominator. So now let's go ahead and actually simplify this, right? So the numerator is just going to be, since we're multiplying by 1, we're essentially expanding out this term right here. So that's going to be x squared plus 5x plus 6. And the denominator in this case, so let's be explicit here, right? So this is where being explicit is critical. So I'm going to distribute the denominator, and then we can see where we get our nice canceling effects. So we'll look at this first term right here. This x plus 2 is going to cancel with this x plus 2, and we'll be left with x plus 3. And in the second term, x plus 3 is going to cancel with x plus 3, and we'll be left with x plus 2. So I'll just write that again. We're going to be left with x plus 3 here, and x plus 2 here. Now if we simplify one more time, our numerator stays the same, and our denominator becomes 2x plus 5. So in this case, our answer choice is B. Okay, let's move on to problem 14. In problem 14, we have 3x minus y equals 12, and we're asked to find the value of 8 to the x over 2 to the y, right? So you might be wondering, well, where do we even start with a problem like this, right? It seems a little, seems kind of abstract. This is actually a really interesting problem because we're going to be using both types of our exponent simplification rules. So I'll call those out as we see them, but to answer the first question of where do we start, I would really recommend when you have this type of expression where you have different bases and you're doing operations with them with different bases, to try to find a common base. And we can do that pretty easily here, right? So 8 is equal to 2 to the third power, right? So our common base, so now we can see that we can get a common base of 2. So that must mean that 8 to the x is 2 to the third, 2 raised to the third power, again raised to the xth power. So this is the first question we need to answer, is how do you simplify something like this? So let's look at an example. I think that understanding this exponent rule is much easier by looking at an example. So suppose you had something like this, right, where you had 5 squared raised to the third power. So what does this mean for us, right? So 5 squared raised to the third power. So that's the same thing as saying 5 squared times 5 squared times 5 squared, right? That's what at least raising something to the third power means. Now each of these 5 squareds is the same thing as 5 times 5, right? So this is 5 times 5, this is 5 times 5, and this is 5 times 5. So that's the same thing as saying 5 to the 6th power. So what you'll observe, and this is by no means a rigorous proof of this property, right? But I think that this gives you an intuition of what's actually happening here. So you'll observe that if you have a base raised to an exponent raised to a second exponent, like we have here, the result is the base raised to the product of the exponents, right? So 2 times 3 is 6. So that's what we can observe with this example, right? So now if we go back to our original problem statement, 2 to the third power raised to the x power, that's the same thing as saying 2 to the 3x power, right? So we literally just applied this rule over here. So now we can go back and rewrite this expression as 2, so I'll write this, so 8 to the x over 2 to the y is equal to 2 to the 3x over 2 to the y. So now the next question is, how do we simplify something like this? So this is where we can, this is an introduction to our second exponent rule, right? So if instead of saying 5 squared, so if instead of, well, suppose I gave you this example, right? 5 to the 5th power over 5 to the 2nd power, right? So how would you simplify something like this? So that would be 5 times 5 times 5 times 5 times 5 over 5 times 5. So now you'll see that this 5 is going to cancel, this 5 is going to cancel, and you'll be left with 5 to the third power. So what you observe here, right, is if you have a base raised to an exponent divided by that same base raised to a second exponent, the result is that base raised to the difference of the exponents. And you can imagine, and so something similar works. Something similar happens when you have a base raised to the first exponent times the same base raised to a second exponent. In this case, the result is going to be the sum of the exponents. And maybe you can take this on as an exercise for you. You can use a similar process to what we did over here to prove this property, and you'll see that this one also holds true. But what we need to use is this property right here, right? So let's go back, right, and apply this rule. So this is going to be the base raised to the difference of the exponents. So in this case, this is 3x minus y. And now you'll see that we were told that 3x minus y is equal to 12. So this must mean that this is equal to 2 to the 12. So in this case, our answer is A. Okay, good. Let's move on to problem 15. In problem 15, we're told ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14 for all values of x. So for all x. So this little upside down a is a mathematical shorthand for all. And we're also told that a plus b is equal to 8. And now we're asked to find the possible values of c. There are two possible values and we're asked to find both of them. So how do we go about doing handling a problem like this? Well, I would say the first step should be to simplify the left-hand side of the equation. Right? So let's go ahead and do that. So that's going to be ab times x squared plus, so then we have 7a plus 2b times x plus 14. And that has to equal to 15x squared plus cx plus 14. You might be wondering why I wrote it this way, and I'll try to explain that momentarily, right? But I'll note again that this has to be true for all x. Now, why do we keep stressing this, that this has to be true for all x? Well, this condition is what allows us to take our next logical step. Because this is true for all x, right? This must be true when x is equal to 0, when x is equal to 50, when x is equal to 100, when x is equal to 1,000,000, right? So think about what's going to happen to this equation, right? When x is equal to 50, for example, right? This quadratic term is going to blow up really quickly. This linear term will blow up moderately, and this affine term, this is what this constant, right? This is just going to offset our total value by 14. But the important thing to notice is that we need both expressions that constitute our equation to be true at all values of x, right? And if it's going to blow up over here when x is a very big number, right? Then we must have it blowing up at the exact same rate. Otherwise, we'll never be able to match this, right? We'll never be able to match the growth, and we won't be able to, and this equation won't hold true for all x. In other words, because this equation is true for all x, it must be identically true. And that means that each coefficient of each power of x, so I'll write this out, so each coefficient of each power of x must be equal. And if that's true, then we can say that AB is equal to 15 and 7A plus 2B is equal to C. And luckily, not luckily, but this has to be true. 14 has to be equal to 14, right? So we don't have to write that out. But this is the reason why we need this condition to be true, because it allows us to take this logical step, which allows us to make this statement. And now, if we look at this statement, right, we know. Let's consider. So I'm going to call this equation 1, right? So if we look at equation 1, right, if we combine that with the fact that a plus b equals 8, then that implies that if A equals 5, then B equals 3. Or if A equals 3, then B equals 5. Now, how did we arrive at this? Well, what we would do is we look at the factors of 15, right? And the factors of 15 are 15 and 1, whose sum is 16, right? So here the sum is 16, and we look at 5 and 3, whose sum is 8. Now, there's no restriction placed on whether A is 5 and B is 3, or A is 3 and B is 5. So we have to consider both cases, right? So let's call this equation 2 and equation 3. Or expression 2, expression 3. So if we look at statement 2, and we combine it with, let's say, statement 4, right? Then we have 7 times 5 plus 2 times 3 equals C, which implies that C is equal to 41. On the other hand, if we look at statements 3 and 4, we get 7 times 3 plus 2 times 5 is equal to C. And we get that C is equal to 31. So if we look at, so this basically gives us both values of C, and you see that that matches up with answer choice D. So I think we can leave it here for this video. We'll conclude the rest of the of this section of the 2018 practice test 1 section 3 in the next video. See you then.